Hello everyone, my name is Joshua Olusegun Ajetomobi. It's my pleasure to welcome you to a tutorial on data manipulation and descriptive statistics. We shall begin with data manipulation. The starting point is to set our working directory. To set your working directory, you move to session here, set working directory, choose directory. My directory is business analytics folder. It's on my desktop. There you click open. So it's already set. If you click on file here, for instance, you will have all the files in that your directory. After setting your directory, the next thing is to install and load the data that you would like to use for data manipulation as well as descriptive statistics. We shall use dplyr package. So in order to load that package, you type library dplyr. But in case you have not installed the package, that is very simple to do. If you have not installed the package, you will come here and click on packages. So when you click on packages, this is install. So you click on this install. Then you will have to type dplyr here. dplyr. There you install. I don't have to install since I have the package already. The data set we want to use is fdat. So go to file here, check for that data set. This is fdat here. It's in CSV format. Click on it. You see view file, import data set. So you click on import data set. It's already retrieved. So you say import. So you have the data set. The data set is extracted from World Bank Enterprise Data on Nigeria, 2014 WB data. It contains 825 manufacturing firms, and we have the size type, that is whether it is small, medium, or large. We have cost of building, cost of machinery. We have the size in numeric form, 1, 2, 3. Then we have ownership, whether domestic or foreign. We have city covered during the survey. Then the industry. The industry is limited to agricultural related industries in this particular sample. Then we have sales, labor, that is the number of employees, materials, cost of intermediate inputs. Then we have capital. So let us return to our script file. In data manipulation, it is always good to record the names, that is the column names, the names of the variables. To do that, you just need to type names. This fdat. So these are the various names. Sometimes we may wish to rename some of those names depending on a particular interest. But to teach us how to rename, I want us to rename size type as firm size and ownership as firm owner. In order to do that, I call the new data I want to create EFF. So I want to rename firm size, firm owner in FDAT. So I say FDAT. This sign, percent greater percent, in layman language in R, it means then it's a pipe operator that is linking the objects on the left-hand side with those ones on the right-hand side. So this is rename. Usually you have to start with the new name equal to old name. Don't forget that one, because if you type old name equals to new name, you will not get the answer. So the new name is firm size equals the old name, which is the size type, comma. And the other one, the new name is firm owner equals the old name is ownership. The moment you have done this, run it. So check the names again, and you will see that the names will have changed. So here you have seen that you now have firm size instead of size type. Then you have firm owner instead of ownership. You can do that to any variable. In data manipulation, the next thing is we want to learn how to select variables needed for our analysis. Sometimes we may have many variables, but usually you have to limit the number of variables you need to those ones that are essential for the analysis you want to carry out. So I call the variables I want to select EFF underscore var. I'm selecting the variables from EFF, so percent greater percent. You have to just say select. So let us select firm size, industry, sales, labor, capital. Let me move this so that we can see clearly what we are selecting, and material. So let's select these 6 variables. So the moment you have done this, let's run it. Yeah. So after running it, check the names. You will see that your names will be limited to just 6 variables. Now you can see that the names of the new data, the new objects that we have created is limited to just 6 variables that we have selected. The next thing we want to learn is how to label the variables. How to label the variables. To label variables, we need labeled package. So this labeled package, don't forget, if you don't have it, then you have to install it. So library labeled, let me run it here. Beautiful. To labels, very, very simple. So this is my object, f percent greater percent. The function is set underscore variable underscore labels. So I want to label my firm size, which is size of the firms. Industry is the name of industry. Sales values in Naira. Labor, number of employee. Capital, building and machinery cost in Naira. Materials, cost of intermediate inputs. This is very, very essential so that I will know what those symbols actually means. And so let me run it. Beautiful. So you may wish to check the variable labels. Sometimes when you are using secondary data, the variables are already labeled. So sometimes you may just wish to check the variable labels. To do that, the function is look for. So this is my object. Labels is equal to true. This capital T means true. Then details. My details could be full or none. So I don't really want full. I just want just the names of the variables. So if I've done that, then I want it in long format. So, and the data frame, so that nothing is hidden. Run. I've done this. You can now see it clearly. So you can see that my firm size of firms, industry name of industry, just as we have defined the variable labels. So the next thing we quickly want to learn is arrange. Arrange means sorting our variables either in ascending or descending order. So let us do that for sales, for instance. So we have our object L equals to level percent greater percent. Arrange. This we arrange sales in ascending order. So let's run it. It's wonderful. So you can check. So you can see clearly. Let's look at sales. So we have sales. You can see that the minimum is 22,000, followed by 54,000, and so on and so forth. This is already arranged in ascending order. If you want to arrange in descending order, you have to put DES seal before sales. So if you have done that, let's run it here. Good. So check it again. Now you will see that the arrangements here will be in descending order. So this is our sales. You can now see. So this is the maximum, followed by this. So that is in ascending order. So let us learn again how to filter. To filter means I want to obtain a subset of my objects. Take for instance, in our FVAR, if you look at the firm size, we have small, medium, and large. So let's say I just want to extract large. So let me call it large underscore data. So I'm extracting from FVAR, which is that of this is my object, percent greater percent. Filter. So I have my firm size equals. In this case, don't forget you have to use double equal, equals equal, large. That is how to extract large firms. So let's run this. So let's click on this, for instance. It's going to give us, you can see that if you look at firm size now, everything is large firm. So we have 10 with 29 more rows, so I can just add 29 to 30 to make up 39 large firms in the data set. Sometimes we may need to generate new variable. The function to do that is called mutate. Mutate. Take for instance, let's say we want to generate labor productivity, which is the difference between sales and material divided by labor. So to do that is FVAR, which is our object. We have the FVAR here, percent greater percent mutate. So I get my LP as this formula. Let's run it. Run. So if you click on this, definitely you will see that it's already generated. So this is, for instance, this is our LP here. You have all these negative numbers because if you look at the cost of intermediate input, which is material, is actually greater than sales. So that's how to create a new variable. Sometimes we may need to recode. For instance, if you look at the various categories under firm size, you can see that the large is written in small letters. So you may want to have the first letter in capital forms. So if that is what we want, you can have any kind of form depending on your interest in terms of recoding. So let us, for instance, recode firm size as large equals to large. We are just changing this L to capital L. Medium, also changing this M to capital. Small, this S to capital S. You know, this immediately will inform you that R is case sensitive. So let's do that. To do that, we have to mutate, but in this kind of mutate, we have to use if else. So we have our object here, mutate. We are mutating frame size. That if else, that is, if frame size is equal to large, then call it large. If first frame size is medium, call it medium. So usually we don't have to define if else again for the last one, because he is telling us that if it's not large, it's not medium, definitely whatever remain should be termed small. This is just what this one is saying. So let's run this. And you may wish to see what to print it. So to print it, you can now see that the first letters now are in capital form. In data manipulation, also we learn how to group our variables by various category. For instance, let us group sales, summary of sales, labor, capital, materials by frame size, which is something that may interest us. So if that is what we want to do, like call it fval_start. So this is my object here. Group by, I want to group it by frame size. Then I want to summarize each. That summarize means that don't forget this summarize each funds. That is my function. I may have mean, standard deviation, all sort of things. Mean, but I'm interested in mean. So these are my various variables of interest, sales, labor, capital, material. So let's run this, for instance, and so beautiful. So usually this is warning message, not error message. Take note, this warning message. So now you can run this in order to see clearly what your result is. So here we have the frame size, large, medium, small, and this is the average sales, average labor, average capital, and the average cost of materials. So please, if you have your own data, I think it will be better for you to use it to practice. Another thing we can do, you can start with trying to understand this data set, so that you use this data set and see that you obtain the same result as I have here. So detailed descriptive statistics. We need summary tools. Don't forget, if you don't have it, then you have to install summary tools. That's a package, and it's very, very straightforward and super simple to do. I call the descriptive statistics I want to obtain as f_val_descr. That's the name I've given to. You can give it any name of your choice. I say with this my object, f_val, describe. Now the beauty of this is that it's going to extract all the quantitative variables by itself. So you don't really need to worry yourself defining the quantitative or separating quantitative from qualitative variables. So let's run this. Good. So we can look at our result to see the extraction. Okay, let me move this a little bit so that it's going to be okay. Okay, don't worry, but you know, it's scattered sort of here. So I think we will see it clearly when we move it to Microsoft Word. So to move it to Microsoft Word, what you need is view. Take note, by the time you type this view, it's going to show you that it's in summary tools, because usually there are two types of view. We have view in mutate package, we have view in summary tools. Take note, the view in summary tools starts with small v, while that of mutate starts with capital V. So pick that of summary tools. Then you have this what we want to view. Then this is the name we want it to bear in Microsoft Word. So let's run this, for instance, and this will give us detailed descriptive statistics. So I run this. So don't worry, it's saying cannot open file, is because I've given it that name before. Okay, let's do it this way. Let me give it another name. So let me just add the one to this. So, all right. So beautiful. You can see it says non-numerical variables ignored. So that is going to ignore all non-numerical variables automatically. And what are the non-numerical variables ignored? We have firm size industry. So then your output file is written in your directory. You can see this is already in my directory. So let's go to my directory. You definitely find it there. So this is it here, f_var_descript1. So you can just say open with. So you open it with Word. So let me open it with Word. Let me double click. So you can see clearly. So here we are. So if I were you, I think I will redesign my table. So table design, for instance, let me pick something. So let me use this one. This, all right. So descriptive statistics of these are just efficiency variables, for instance. Efficiency variables. Good. I don't need this. I already know that it's 25. Yes, that's all right. So if you look at it, this is detailed. Okay, let's put detailed descriptive statistics, because it contains almost everything that we need. Because we have the mean, the standard deviation, the minimum, the first quartile, median, third quartile, maximum, mean absolute deviation, interquartile range, coefficient of variation, and a lot more. So generated by summarytools 1.1. So let me put the data. So this is fine. This is my table. This is the table I want. So let's go back to our R. If you look at that result, for instance, you know it contains detailed descriptive statistics. Sometimes I may not actually need more than common descriptive statistics, that is the mean, standard deviation, minimum, maximum, number of observation, or just few. If that is what we want, for instance, so let me move this so that we can see the command clearly. So here, what you need is, you will, after descr, this command, you say start equals to common. This will just limit my statistics to common ones. So let's run this and see the results. So let's get this, for instance. Yeah, let me see. Yeah, okay, don't worry. So let's move the results to Microsoft Word like before. So let me put one here, because I already have this there. So this run. Good. So now again, the numerical variables are ignored. Then you have your output file written in your directory. So let me go to my directory. This is it here. So right click here, then open with Word. So you can see clearly now. So in this situation, you can see that I'm not limited to mean, standard deviation, minimum, median, maximum. So unlike before when we have various other ones, then again you can redesign your table in order to suit your interest. So let's go back to our R. So this is, in short, the way to manipulate and obtain detailed and common descriptive statistics. You can practice this. I think the best thing is to start with this data set itself. Ensure that you obtain the same result as mine. Then you can now use it for your data set in order to practice.